ever since then, I've just tried to be a little bit more careful. I don't want to give any insurance fraud people the chance to make me get in trouble again. Okay, so I'm going to sign into this website, as you can see, and I made two temporary copies of this website for you because the thing is, you have to pay for it after 2 weeks. So I don't want you to have to pay for it. Uh-oh. Did they sign me out of this website? Oh, this isn't very good. There we go. Okay, fine. Okay, join, open, start. Okay, I'm just going to share the screen and gonna show you how to do this thing. Okay, so there's basically two options because I can only open it for 2 weeks at a time. So I'm kind of debating about how to do this the right way, but here is the website called Cengage, and basically what I can do is I can send you a class key like this, and you can just go to webassign.net and copy that class key, or I can copy a link, and then you can click on the link. You can either go to webassign.net, which is like this website, and then you just click enter class key, and then you can get put in that class key and get signed in. Or you can click on the link and then do the same thing. Except but today I'm going to show you what you'll see inside of WebAssign. So inside of WebAssign, um, wait, where is that thing? Okay, let me go back. Inside of there, you'll see okay, let me open student view. You'll see a class that says Math 415 Section 1E Fall 2026. And then there's a future one that says Math 415 Fall 2020. Oops, I put in the wrong year because I've been thinking about 2026 for all my other classes. So, and like advising and everything, I'll put it in next year, but that's really for this year's. But there's the early section, which is Section 1E, and then there's the future one, which is going to open up 2 weeks before the end of the semester. And both of them just have a practice final exam in them. So I'm assigning you to work on that final exam and finish it. And I've been debating about this. I'm kind of like, perhaps to like motivate good work and good behavior, like working on it early, I might even let you have like an easier final or something like that if you complete the final review in the early section, like right away and get it all done. But it has to be done within 2 weeks because whatever work you do in this class after 2 weeks is going to close because unless you pay like $90 for it or something. Because these classes that I'm creating are with the textbook that there it has like online access and stuff, and we didn't buy that online access because the other instructor basically just quit his job and never told anybody and just like left and got a job somewhere else in the middle of the summer. And so the whole math department has been like scrambling about what to do. Um, and so I would think I was the only one who had taught this class before, so I just taught the class instead. But we didn't have any like software or anything like that for this course purchased because the other math classes, the math department already like bought this for each student and things. So the only option I have is to let you use the free 2 week access for it. So who would be interested in doing it in the early section, like starting right now, and then finishing that review in the next 2 weeks? Then maybe you can possibly have an easier final than the people who did it later. Okay, perfect. Okay, well then in that case, I'm just going to let you all join that early section and I will show you the class key for it right now. So let me go back to here. Section 1E, here's the class key. And if you get like above a certain percent, let me figure out who's here. Because I don't want to include the people that aren't here because that wouldn't be fair to you. But if everybody who decides to do it early, which is okay, everybody raise their hand, I believe, right? Okay, perfect. So um Amani is not here, America's not here, LaShawn is here. Okay, and then Shamarius, Anthony is not here. Zoe is here. Hold on, there's so many days I need to hold like that ruler up to keep it straight. Okay, Anthony, Zoe. Isaac. Isaac, are you here? Okay, Isaac, do you want to do you want to do the final exam review in the next 2 weeks and then have an easier final? Do you want to do the final exam review in the next 2 weeks and then have an easier final? Or do you want to have a harder final and do it later? Okay. So that's what everybody else voted for too. I'm checking off people who said that. Okay, Anthony Johnson, are you here? Okay, Colin Morrison. Okay, good job. Here. Ignacio, that's you. Okay, perfect. And you raised your hand, right? Yeah. Okay, perfect. Caleb, are you here? Yes. Okay, perfect. And was there anybody who didn't raise their hand? Okay, perfect. So Arturo, are you here? Guess not. Taylor, not here. Logan, are you here? Yes. Okay, perfect. Mercado, you're here. Okay, good job. So all those people, I'm gonna write a note that says do early. Okay, so there is the class key. You can write it down on your page of notes right now. And then I'm going to put the link into Moodle later on, but I don't want to take time out of class to do that at this moment. Just write that number down, friends, and then space 7071 1008. Go to webassign.net, which is just WEBASSIGN.net. Go to that website, and then you have to zoom out so you can see it better, but then click on the button that says enter class key. And then you'll have to probably not only enter the class key, you'll probably have to create a username and password unless you've already used this for calculus or anything else before. So I don't know. I don't think this class only requires college algebra. And this particular software is not used for college algebra. But some of you might have had classes already that did use this website. And if you already used it, then you would have a login already. But after you enter the class key, create an account if you need to, and then you'll be able to get into that early section. And then inside that early section, you're going to find an assignment, and you only have one course visible, which is section 1E. Click on go. And then just do this final exam review, and then okay, now here's what I've been debating about, because I think my only real goal is for you to just learn this, because I don't expect you to memorize everything. Like, you're not going to be a discrete math professor as far as I know. So if you can complete, if the average of everybody who checked this off is at least like 90% or more, then I might even let everybody who said that they do it early to just skip the whole final completely. So I know that's kind of controversial, but I'd rather have you get it all done and like not just leave the hard questions blank. So 1, 2, 3, 4, 5, 6, 7, 8. So the average of all 8 of you has to be 90% or more, and then collectively you'll all be able to skip the final. If your average is only like 85 or something, then you'll still have an easier final, but you won't be able to skip it completely. So just make sure you all get all of these questions done. And starting right now during class, I'm just going to go through them and just like work on each one to just show you how to do it so that you can learn it like twice, once on your own, once with me. Is there any questions? So it's very good that you're in class today. Being in class is super critical. That's another reason why I'm letting you have this chance. Yes. Yeah, it is friends 7071 1008. So feel free to log into that right now and then even follow along if you wish. And the reason it's important to have this system is because some of the questions need like a big picture and like various buttons to press. It's hard to put those questions just in a typed format on a paper test. So it's pretty much a lot easier to learn them and to be tested on them inside this online system as well. Okay, so there's that. Good job, everybody. Now, Okay, so question number one. We've already done this one before, but we might as well start going through the test in just a linear fashion through every question in order. And by the way, some of the stuff we haven't quite learned yet, like some of it's in chapter 12, like finite state automated, or finite state machines. So we're just going to learn what is needed to know as we go. All right, so question number one. Let C equals D both be equal to the same set of numbers, -3 through +3, except for 0. So we've already done this one before, but this point xy is in the set S. It means that 1 over x minus 1 over y is an integer. So I'll let you think about that for a few seconds. So what does it mean if 1 over minus a number minus 1 minus if 1 over a number minus 1 over another number is an integer? That means that that pair of integers, x and y, is in the relation called S. So it says is 2 S2. That means is the pair 2, 2, is that point ordered pair 2, comma 2, is that in the set S? Is a pair 2, 2 in the set S? Which means, in other words, it means, is it true that 1 over 2 minus 1 over 2 is an integer? Yes, because what's 1 over 2 minus 1 over 2? Right. By the way, Anthony, you missed it. Would you rather do this final review early, starting in the next 2 weeks, and have to finish it in the next 2 weeks and then have an easier final? Or would you rather do it later, like in the last 2 weeks of this semester and have a harder final? Okay. Okay, good job. That's everybody else said too. I just wanted to check with you as well. You're welcome. Okay, so Anthony. Okay, so there's that. Is -1 S -1? So remember in your minds what it means to say the -1 S -1. That means that 1 over the first number, right? 1 over the first number minus 1 over the second number is an integer. So is it true that 1 over -1 minus 1 over -1 is an integer? Yeah. Yeah. How about 3, 3? Is 3, 3 in the relationship or not? Yeah. How about is 3 -3 in the relationship? Let's think. 1/3 minus -1/3 would be 2/3. That's not actually. So right S is a set of ordered pairs. And remember, this is only involving those specific numbers. So it says enter your answer as set roster notation. So what we need a pair of numbers from -3 to +3 and not including 0, such that 1 over x minus 1 over y is an integer. What would the first pair be? How about -3, -3? Remember, we already talked about this before. We remember we decided that this relation is reflexive. Who remembers what reflexive means? Every number in the set is related to itself. Because for any value of x and y, 1 over x minus 1 over y would be 0 if x and y are the same number, right? And 0 is an integer. So -3 would be related to -3. -2 would be related to -2. -1 would be related to -1. +1 would be related to +1. 2 would be related to 2, and 3 would be related to 3. So that's true. Everything is related to itself, according to that definition. So do you see how this requires understanding? It's not hard, but it requires you to understand what's going on. So every single 1 over this minus 1 over this is 0. So every number is related to itself. Are there any other numbers besides themselves that are related to another number? Well, not quite, because if you divide by 1, you always get an integer, right? So every possible combination of 1, even like 1 -1 and 1 positive, and -1 +1, those are related to themselves because when you divide by 1, it's still an integer. It's not a fraction, right? And what about 2? If you take 1 divided by 2 minus 1 divided by -2, would that be an integer? What's 1/2 plus 1/2? 1. So that means 1 over 2 minus 1 over -2 would be related. Those two paired. And what about -2, +2? Would that work? What's 1 over -2 minus 1 over +2? That's -1/2 minus +1/2, which is -1, which is an integer. But other than that, I can't think of anything else. I could be missing something. Can any of you think of anything else? That 1 over x minus 1 over y would be an integer, starting with the numbers -3 through 3. Okay, so what's the domain of S? Just like you learned in college algebra, the domain of a relation is all the x values of it. The -3, -2, -1, 1, 2, 3. That's all the x values. You don't have to list an x value twice. So even though 1 happens twice, you don't have to list it more than once. What's the codomain of S? That's all the y values. Well, that's actually all the values in the target space. So it's basically just the set of, well, then in this case, the domain and the codomain are both the same. So -3, -2, -1, 1, 2, and 3. Which of the following arrow diagrams represents S? So an arrow diagram is just an arrow that for every x value, there's an arrow that goes to every y value that it has. So the x value -3 only has one y value. So let me zoom out a bit. So -3 only has, okay, so it's not that one because -1 only goes to one spot. So it's not that one. It could be this one maybe, because -3 only goes to one spot, but -2 goes to both -2 and +2. -1 goes to both -1 and to +1. +1 goes both to -1 and to +1. 2 goes to -2 and 2, and 3 goes only to 3. So I believe it's that one. But we need to make sure that we pick the best answer, so it's not that one for sure. It's not that one for sure, because -3 can't go to two different numbers. So it's got to be just the second one. So there we go. Okay, submit answer. And it'll tell you right away whether you got it right or wrong. Let's just check and see. Processing it. So we got that one right, that one right, that one right, that one right. We got everything right. So we got 8 points out of 8 on that one. So good work. You ready for question 2? Okay, so question 2 is about a graph. So which edges are incident on vertex 1? So which edges basically touch vertex 1? So there's vertex 1, and vertex 1 is touched by 3 edges, right? It's touched by, who can tell, so the edge is one of the blue lines. Who can tell me the 3 blue lines that touch vertex 1? It's kind of hard to read 2 of them because they're covered up by the blue line. E1. E7? Yeah, E1, E7, and E2. Yeah. And by the way, to make the subscript, you do an underscore. So what I'm actually typing is E underscore and then 1, and then I use the arrow key to go to the right to get out of the lower line level of text. And then so when I'm down there, I have to push the arrow key to the right to go back up to the top line. So that's the first ones. Let me just check that answer one at a time, make sure that we got it right. Okay, perfect. Which vertices are adjacent to V3? That means which vertexes, now vertexes is not the right word, but to me it makes more sense. I shouldn't say it though. It's a bad habit. Which vertices are adjacent to V3? That means which vertices are next to or connected to V3. So there's V3. There's only 2 vertices that are connected to V3, which are V3 is connected to V1 and V3 is connected to V2. So V underscore 1 over with an arrow comma, V underscore 2, those are connected to V3. So those are the only answers to that one. So let's check the answer real quick. Okay, perfect. And by the way, if you want to enroll in this thing and work on it in real time, if you got here late, you can go to webassign.net and type in that class key. And then just use temporary access. It'll last for 2 weeks. That's why we all had agreed that we would get it done within the next 2 weeks. Otherwise, you'll have to join a different section of it. But you can't join the next section because it only can open up in 2 weeks, so you'll have 2 more other weeks to do it. Because this particular website doesn't depend on when you enroll, it depends on when the class is opened. So if I open it right now, you can only have free access for 2 weeks. So that's why the other one won't open in for another 2 weeks. Okay, so then, wait, this is getting in the way. Who remembers the keyboard shortcut to go to the next tab? Okay, there, never mind, it went away. What? Alt arrow, let me try it. Alt arrow. No, that didn't work.
Control.
Um, yeah, there's probably a control tab. Control tab. Yeah, that's right. Okay, so sometimes when the toolbar gets in the way, I can't click on the next tab. I'll remember that. Control tab, that's perfect. Okay, so then which edges are adjacent to edge 1? So which edges are linked up to the same node that E1 is touching? So edge 1 is touching vertex 1. So which other edges are also touching vertex 1?
E2 and E7.
Correct. So which edges are adjacent to E1? Here's E1 right here. There's E1 touching this corner. So edge 2 is adjacent to that, and edge 7 is adjacent to that. So E2 and E7. So E2, comma, and E7. That was an easy question because E1 was only touching one vertex though. But what about what would just imagine what if it asked you what edges are adjacent to edge 2? Does anybody know which edges are adjacent to edge 2? It'd be edge 7. It'd be edge 6. It'd be edge 3. It'd be edge 5 and edge 4. Yeah, pretty much all the edges would be adjacent to that because all those edges are connected to the same link up point. So imagine that that's a telephone pole. Imagine there's a telephone pole right here in the middle of the neighborhood, and edge 2 is connected to the telephone pole. Any other telephone line that's connected to the same telephone pole is considered to be adjacent to edge 2. Okay, so then which edges are loops? A loop is something that comes back to the same vertex and it doesn't connect to a different vertex. So edge 1 is a loop and edge 3 is a loop. Edge 1 and edge 3 are loops. Edge 1, edge 3 are loops. Which edges are parallel edges? Parallel edges, they don't necessarily go the same direction, but they connect the same two vertexes together. So imagine that this is a huge city like Dallas and this is like New York. There might be two cables connecting to the same cities, maybe side by side. So those are parallel. So edge 4 and edge 5 are parallel. I do not see any other parallel ones because there's no other edges connecting the same two vertexes together. This only has one, this only has one, this only has one. So edge 4 and edge 5 are the only parallel edges. We're what they were, edge 4 and edge 5. Edge 4, edge 5. Which vertices are isolated? Those are the ones that are not connected. So vertex 5 is, I'm sorry, vertex 4 is isolated, right? Vertex 4 is isolated. What's the degree of V3? So it's how many links are connected to it. So how many links are connected to vertex 3? Yes. So vertex 3 has 2. So let's submit those answers. I wish we could have had a little bit more time to talk about some cool theorems about these graphs. Okay, but that's good. So at least you understand about edges, what edges and vertices are in graphs. Okay, now question 3. Select a symbolic form for each of the following statements. X is greater than or equal to 5. So X is greater than or equal to 5 represents which two of those statements? It represents greater than 5 as well as being um, equal to 5. Now, does it represent both of those things with an and, or does it represent both of those options with an or? With an or, because you can't actually be equal to 5 and greater than 5 at the same time, right? So it only could be an or. So X is greater than or equal to 5 would be the statement P and then the symbol or and then the statement Q. So P or Q. Now let's logically represent the statement 12 is greater than X is greater than 5. So which two statements does that represent? It represents that one and that one. Now, unfortunately, you can't select two different things at once in the browser. Even if I hold down the control key, I can't select them both at once. But imagine that P and R are both selected. That means P as well as R. Would those two statements P and R be joined together with an and or with an or? Yeah.
I don't think it's or I don't have the same exercise in here.
Yes, yeah, they're different for you. They're randomized. So you might have 14 or 15. Yeah, of course, they're not going to be the exact same numbers. But you do have a question about the same thing, right?
Yeah.
Yeah, right. Okay, so um now, so yeah, you have to work on your own questions in order to get the credit for it. But would these be joined together with an and? So does 12 is greater than X is greater than 5? Does that mean that 12 is greater than X or X is greater than 5? Or does it mean that 12 is greater than X and X is greater than 5? What does it mean? It means and, right?
Yeah.
So that means they're both statements and then an and between them. So it means P and R. So that would be P and R, which is the first one, or R and P, which is the same as P and R. How about 12 is greater than X is greater than or equal to 5? What does that mean? 12 is greater than X, and then X is greater than or equal to 5. What does that mean together at once? That means R, that's the first part.
Oh.
And then, yeah, it means R, and then and the other side is true as well, but the other side has an or in it. So you have to put it in parentheses. So it's P and then in parentheses, the parentheses are critical, Q or R. So P, no, sorry, 12, R actually. R comes first. R comes first, and then the and. R means the 12 part of it, and then and in parentheses, P or Q. Because if you don't have these parentheses there, it will not mean this group together at once. So it means 12 has to be greater than X, and then in parentheses, the whole thing has to be true that P or Q is true. So that's cool. Okay, so there's that. Now let's go to number 4. Use De Morgan's laws to express the negation. So what's the negation of the statement A or B? What's the negation of the statement A or B?
No, A
Not A and what? Not B, right? So it'd be the train is not late or my watch is not, oh, sorry, my fault. The train is not late and my watch is not fast. So the negation of A or B is not A and not B. So it's the train is not late and my watch is not fast. So there's that. Okay, perfect. Now number 5. So is not P or Q or P and not Q a tautology, a contradiction, or neither tautology nor a contradiction? Well, we have to figure it out. So let's fill this out. So I want to have you tell me everything to put. I don't want to fill in any of the answers myself. So now I don't want to ask for the same person all the time, but I don't want to force everybody to answer. So work together in groups of 2, and then well, let me think. How many people are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So there's 5 groups of 2. So let's see. Zoe, you work together with Ignacio. And then Arturo, you work together with Anthony. And then Isaac, you work together with Logan. And then the back row work together. And then Lashana and Mercado, you work together. So I'll ask each of you groups for some of the answers, 2 at a time, not 1 at a time. So first group, Zoe and Ignacio. What is the first column supposed to be? It says not P. So to talk together and figure out what is not P for those, and then tell me those 4 answers.
Alright. So then like this. False, true.
Okay, perfect. False, false, true, true. Good job.
Wait a bit.
And then now the next group is Arturo and Anthony. Can you tell me what not Q is?
False, true.
Yeah, false, true, false, true. And then the next group, it's getting a little harder. The next group is you two, right? Isaac and Logan. Can you tell me what? So look carefully with the column. It says not P or Q. So you're going to be looking at these 2 columns. So look at these 2 values, these 2 values, these 2 values, and these 2 values. And when it says the symbol, it says between them is the symbol or. So remember, an or is always true unless both values are false. So an or is always true unless both of the original values put into it are both false. So the only time it's going to be false is right there. The other 3 times it's going to be true. So keeping that in mind, I'll let you tell me what to put for each of these 4 answers. What should I put for the first one? Correct. What should I put for the second one? Correct. What should I put for the third one? Right. What should I put for the fourth one? True. Right. Because the only time a or is false is if both of the input values, which are these 2 letters right here, are both false. That only happens once in this row. So there's only one false in that or statement. Okay, now the next group, which is going to be the back row, P and not Q. So let's find those columns. P is right here, and then not Q is right there. So it's the first and the fourth columns, P and not Q. And with an and, it's the opposite of an or. So the only time an and comes out to be true is if both of the input values are both true. And P and not Q, it's only both of them are true only once. So P and not Q is the only times both values are true is that one. So that one's only going to be true one time. It's only going to be true on that particular line. The other 3 lines are going to be false because they're not both true in any of the other 3 lines. So keeping that in mind, I'll let you tell me what to put for these 4 answers. False?
True.
Yeah.
False.
Right. Good job. Okay, perfect. Now, finally, the last and biggest one for the final group. This one is putting together this entire value of this, not P or Q. It's this. Okay, actually, first, before I do that, let me just check these answers because I don't want to make you get it wrong because maybe just in case the other answers are wrong. Let's check those answers. Okay, those answers are all good. Okay, so Now we're ready. So for the final column, we're taking the not P or Q value, which is this column, and then we're taking the P and not Q value, which is that column. And what are we putting between them? What does that symbol mean? That means in what? An or. So we're doing this column compared to this column with an or operation. And an or operation is only false when both values are false. So are there any times when both of these values are false? No, 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 no. The values are never both false. So that means that the value is always going to be true. So keeping that in mind, what should I put for these four values? True, true, and then what next? True and true, because it's never false because there's never a time when both input values are both false. And an or can only be false when both input values are false. So that's perfect. So is it a tautology? A statement is a tautology if the full statement comes out to always be true. And that does come out to always be true. So this full statement itself as a whole, not each part of it, but the entire thing as a whole, is a tautology. So it's true for every value. So therefore the entire statement as a whole is a tautology. So submit. Good work. Perfect. Okay. Now, number 6. We use a truth table to establish the truth of this statement. So do you want to stay in the same groups?
Yeah.
Okay. So group number 1, which is Zoe and Ignacio, tell me together what I should put for the first column of the answers.
False.
Yeah,
False.
False, true, and true. Okay.
right. Good job. Okay, perfect. And then next group, Anthony and Arturo, what should I put for the next column?
False, true, false, true.
Yeah. Good job. And then, okay, now I have to explain this one a little bit before the next group goes. So let's review a conditional statement. P implies Q. The statement P implies Q is kind of like a promise that I'll do something today, that if I do something today, then you'll do something tomorrow. So it doesn't say that I will do something today. It just says if I do something for you today, then you'll do something for me tomorrow. That's like a contract or whatever. So the only time a contract is broken is if the first part did happen, but then the second part did not happen. So it's only false in one case, which that case could happen several times, but it's only false when the P or whatever comes first has to be true. What happens next has to be false. So look at P and Q together. Is it ever the case that this is a true, but that's a false?
Yes.
And it happens, how many times does it happen? How many times is the PQ true, but the Q is false? Once. It's only happened then. So that's the only time that this contract is going to be broken is in that spot. So the other three times it's going to be true. So it'll be false right here and then true, true, true. So keeping that in mind, tell me what I should put into the boxes. Right. Good job. So let's check all of those real quick. Perfect. Okay, now the next one says not P implies not Q. So now the contract is talking about the input values to this contract are this column and then this column. So this one is implying that. So the only time that can be true is if the first one is true, but the second one is false. So wait, no, did I say it backwards? The only time that contract can be broken is if the first one's true and that one's false. So does it ever happen that this one's true, but this one is false? Yes, it happens right there, right? So on this line right here, the first part of the contract was kept if this did happen, but then the contract was broken because then this part did not happen. So this line right here is the only time that this contract is gonna be false. The other three times it was not true and then false, so therefore it's not gonna be false, so it'll be true. So tell me what values to put down for this column right here, the next group. I forgot which group it is. 1, 2, it's you, okay. So what values should I put right here, given that the only time this contract is broken is in this column right here. That's the only time it's broken. So this is the only time it'll be false. So what should I put?
Yeah.
TT FT. Right. It's too bad there's not an N because then you say TTFN. Ta-ta for now, like a cartoon. Okay, so what's true? I'm sorry, my fault. TTFT. Okay. So let me check those answers. And what does this truth table show? Does it show that those two columns have the same values or not? The truth table shows that P implies Q and not P implies not Q. That's this column and this column. Do they have the same values all the way down? Or do they have the opposite values all the way down? Or do they have neither the same nor the opposite values at certain points? So do they always have the same truth values or what?
No.
They do not always have the same truth values. So therefore, a conditional statement is not logically equivalent to the inverse of it. By the way, this is called the P implies Q. The inverse of P implies Q is not P implies not Q. Remember, the inverse of a logical statement means that you replace each proposition with the negation of the proposition, but you keep the symbol in the middle of them in the same order. So there's that. Perfect. Okay, well, let me see if there's enough time to do the next one, if it's a fast one or if it's a slow one. Okay, so this is kind of a fast one, so let's go ahead and do it. So suppose that P and Q are statements. So the P implies Q is false, right? Now we remember that there's only one case when P implies Q is false. Who remembers when that case is? When is it true? If you have paper to write this down, if it says that P implies Q is false, and that can only happen when? When P is true and when what?
It's false.
Right. So we know for sure that P is true, Q is false. Now that we know that, what would not P be equal to? What would not P be equal to? If P is true, then what's not P? False, right? If P is true, then not P is false. And anytime that you have a false here, that means the implication is automatically true. Do you know why? Because the only time an implication can be false is if the first part is true and the second part's false. So if the first part is not true, then it's automatically true. Okay, what about the next part? Well, we know P is true, and we know that an OR is always true unless they're both false. So since P is true, we know that the OR is true because they're not both false. And then how about Q implies P? What's the truth value of Q implies P? Well, on your paper, write Q implies P. And remember, we know that Q is false, right? So if Q is false, that means what? If Q is false, because we already know it's false from the beginning. If Q is false, we automatically know that this has to be what? True, because anytime the first part of an implication is false, it's automatically true. Because an implication says if something happens, then something else will happen. And if the first part is false, that means the first part didn't happen. So the whole promise is automatically kept because it doesn't have to be kept because nothing happened, basically. So there's that. So let's check that. So that's all for today. We'll come back and work more on this review together. Make sure. So the deal is, if you can, that you agree to, is if you come here, if you join the early class and you finish the final. So how many people are there right here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 people here now. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, who am I missing? Who came here last? Arturo? Okay, so here, let me tell you about the deal. So if you do the final exam in the early section of the final, the review. We're doing right now the early review. If you do this review, then you'll have an easier final. But if everybody who does the early review gets at least 90, if the average of everybody is at least 90%, then this group of people won't have to do the final at all. If you get an average, if these 10 people get an average below 90, then you'll have to take an easier final, but you won't have to take the harder final. The people who did not do the early review will have to take a harder final later on. So make sure that you try to get at least everybody try to get 100, obviously, because if one person drags it down to like 80, then the other people need to bring it back up higher. So make sure that you get all of these questions done and all of them right. Good job, everybody.